As we're dealing with requirements, one of the key processes that we want to talk about is configuration management. And configuration management is a very fancy way of basically saying change management, dealing with changes. But the configuration being the network of artifacts and how they kind of deal with each other. And configuration management extends past requirements for sure. You can just deal with, okay, I have software, and my software has configuration files, and so this is the management of that bundle of files that makes up my system. That's another aspect of configuration management. I'm checking in code and giving many different versions of code. Configuration management helps me keep track of that stuff as well. But again, for those of you who are familiar with the term, we're looking at this at a little higher level than just checking in and out code. Because when we build the software, when we build the code, it is based off of this whole network of different components and different descriptions and different documents and things that I'm putting together to solve that whole problem. And so the quality of each of those parts depends on that whole network in which they live in. Remember, not all software is built as some big cohesive block. You build a house, well, typically they're all connected and that's all you expect it to do. But if you build the International Space Station, it's made up of a bunch of interchangeable parts. And if I put the wrong part in the wrong part of the space station, they might not connect properly. Or as the space station gets older, maybe I want to replace a certain part with a new part that upgrades it. And I need to make sure that that new part conforms to the old pieces and fits in there, but then has maybe some advanced upgrades that come along with it. And maybe I'm upgrading different parts at different times. So I might have to build a science lab that deals with a lower power threshold, but then in another year when we upgrade the mechanics or something like that gives us more power on the station, maybe I can upgrade later on. And so that configuration management helps me know where I am in that component at a given point in time. So in the software environment, it's very dynamic. I mean, we talk about the International Space Station having have a very distinct interfaces. Well, softwares can be used in even more context than that. I could write a component that does some sort of math operation, and then who knows how many different applications that might have applicability in. I could be doing a math operation in a GPS receiver, and I could take that math operation, go over and do it in some research software, do some statistics, or I could take that over and put it on a financial application, and that same math package has to function in all those different configurations, all those different application approaches. So the interconnections between the pieces hopefully is more stable, but particularly when those things change, it becomes really important that I understand how my system is changing as a whole. Part of configuration management is understanding if one piece changes, how does that affect the other pieces? Some pieces can be changed out, make no big deal. They function the exact same way. Maybe they do it more efficiently. Maybe you could do more of it, but it doesn't change. Performance change only. If there's a functional change, though, I need to understand what's the ripple effect of that. And that's where, in particular, requirements changes can have a big impact. Because fundamentally, software changes. You might find an error in the system, you have to go fix some code. You might create, hey, this would work really well over there. Let's go build it to do this thing. Or I just make new features. The requirements changes it's often viewed as something negative. Because hey, it changed. We had this project plan and somebody changed something and my gosh, we might be later than we originally planned. Well, if I said to you, you're off there building something that's going to, make $100 a day for you, and you're gonna, release that, in a month, and then you'll start making $100 a day. And I said to you, well, wait, if you make this change over here, it's gonna get you $1,000 a day, but it means you're gonna have to release it a week later. Well, of course, you had no trouble. So, unless you're really desperate and you need that $100 a day really, really bad, or you're going to not be able to finish, if you can delay it for 7 days, well, that's $700. You'll make that back the first day. You can delay the week, you make it happen. Now, sometimes you can't. You can't wait a week. I need the money now. Sorry. Other times, sure, that makes a lot of sense. So, remember, not every change is bad. You'll see some stuff out there that talks about change management. I need to control changes, and changes are dangerous to software projects. Well, they're dangerous if you don't have a process to understand and control and manage the changes. If I can control the impact of the change, then I can be on top of it. I can say to you, here's the trade-off. I make this change. This is what happens. I need to spend an extra $1 million. I need to go and delay the project for a week. I can reset on time, but I can release that feature, but I have to drop some other feature. There's all sorts of different impacts to changes. Some of them, again, could be good. I once requested a requirements change that they fought back on. No, we can't risk that. We can't make changes. We change the requirements, then we would risk the project. I'm like, well, wait, no. If you make this change, I write less code. I can get my code done. If you keep the requirement as is, I'm going to have to spend an extra 2 weeks coding this thing. If you make this change, I can be done right now. Go with it. It makes sense at that point. So not every change is bad that's happening, and some changes are bad but need to be done anyway. Because if I release something on time that's useless, it doesn't do us much good. So configuration management, software configuration management formally, is the practice of making sure I understand what happens when something changes. And so we want to focus on identifying the changes that happen and what the ripple effect of that change is. Controlling the change, so, having the change happen in a orderly fashion and in a way that we can predict, and assuring that we made the change completely and correctly with notification of what the heck just happened. Again, this might be something as simple as I checked in a file, does it all still compile? It might be much more involved of I need to change a high-level requirement. What teams need to be notified? What subcontractors do I need to let know? What updated documents do I have to have? What code is going to be impacted? What's the total cost? So it can happen at all levels inside of here. The idea of change then means I have to baseline an approved set of what we think is happening in my application. So these are the requirements that I think we're building. This is the design that ties to those requirements. This is the code that's implementing that design. These are the tests that test all the stuff that we just talked about. That baseline of artifacts defines a state that we're trying to get to, or a state where we're at, either way, based off of whatever the network of dependencies are. Your code is dependent on your design is dependent on the requirements, the tests are dependent on the requirements, and the design a little bit too. So if I don't change the requirement, I change code, I'm not worried as much about the ripple effect of that. The code's pretty far down the list. But if I change the design, it might impact the code, could impact a few tests. If I change the requirements, it very well probably will impact all the above. So the interconnections is part of what I want to understand in the requirements. And this is where traceability comes in. We have that traceability matrix. So when I write a requirement, I want to have that thing be numbered, like we talked about. I want to have an ordered list, 1, 2, 3, 4, 5, or give it a requirement number like banking account requirement 1, or within use cases. That's a good way to do it as well. Within use cases, I number my steps, I number my alternative flows, things like that. That gets me to where the requirements come in. And so I can have a test that verifies the requirements. I can have that test point to specific types of requirements, list of requirements, names of requirements, or even steps within requirements. Then I've designed that implements it, and the test that verifies that, and the code that implements it. This is a simplified representation of the complex stuff that goes on. Some projects will actually get down to this method ties to this requirement. Other projects are more like, well, okay, we have the requirements. This design covers which parts of the requirements. So I'm working on the payment system subsystem. It does chapter 17 of the requirements, as opposed to the security login requirements, which are covered in this other design over here. Things like that. There could be some higher level SWAC at it, but the point is we have interconnections, and that helps us, by knowing that, control the changes. So when somebody comes in and asks for a change request, that's a formal process. It says, hey, I would like to have this thing changed. It allows us to go to that network that we just saw. We can go back to this and say, oh, if you change this thing over here, then it's going to have this requirements change, and then it's going to imply this part of the design might change, and I'm going to have to update these tests based off of that. And then if I change this part of the design, I'm going to have to fix these tests and this code, and you can propagate it down. You can see, is there 8 things to change, or is there 800 things to change based off of that? But we do that by formally controlling how we ask change. We don't just start making them. We ask, how is this going to impact it? And then we approve that change. So if the change request is deemed to be something valuable in relation to the cost or essential in relation to the cost, then it's approved. Otherwise, we may defer the change, we might decline the change. No, we're not going to do that. That's part of your project management process, particularly around requirements changes. And so when I make a change, I need to make a change against a baseline. And that baseline then is going to be updated, but I keep what the old baseline was. So I know when the requirement was you shall accommodate 8 users, this was how I defined the system I was going to build. When I change that requirement to say the system shall hold 8,000 users, well, these are the impacts of it. This is the new baseline I'm going to create, where instead of designing it for 8 users to be on an individual laptop, for 8,000 users, I'm going to have to create servers and figure out artifacts and things like that. That's a hardware view of the world, but it's okay. Sometimes we do view the world as hardware and software, and software projects do include hardware as well. But just remember, in this class, we are mostly worried about software development. This is mostly looking at that. We do have some hardware connotations. I don't want to say hardware requirements are easy to figure out, but compared to the dynamic nature of functional requirements, it's not what we want to spend as much time here. All right, so this week then, you're looking at and talking about these different processes around requirements. And again, there's a lot of process beyond what requirements phase is, but the requirements does come back, and change management is a critical part of understanding and working through the requirements process.